Hello, everyone. Have you had a good time? Yeah, let's pump it up. How are you? Woohoo! Yeah, last day of the conference. Thank you so much for joining me here. Last day, everybody's tired. I am tired too. So let's get going. I'm here to talk about NeuralProphet, Axon, NX, and of course, Livebook. This is a Livebook conference. So lots of great stuff. So yeah, let's forecast stuff using algorithms. Nothing to worry about. So only great stuff coming. So yeah, only great ideas coming from that, right? So let me tell you a little story. Zillow lost more than $300 million after a data science model went rogue, according to Bloomberg. So they had this feature on their site, Zillow, where they offered Zillow offers, where they offered money and to buy homes based on their prediction model, on a neural network model. And guess what? According to some people, they were using NeuralProphet, so the stuff that I'm going to talk about. They're using NeuralProphet to forecast what's the predicted value of that home is going to be in a few years, a few months. And based on that, they're going to offer you money. And usually that offered money was so valuable that people sold their money, sold their homes to Zillow straight away. And they inflated the home market. Reportedly, they lost a lot of money for that. So actually, and maybe the theme, the title for this talk could be, let's learn how to lose $300 million fast using Elixir, using Livebook and friends. Should be a great way, should be a great takeaway to go into our workplaces with that, right? So yeah, let me introduce myself. My name is George, or in Portuguese, George Guimarães. I was a co-founder at Platform Attack together with José Valim, together with Hugo Baraúna, who talked about Livebook in the first day of the event. And previously, I was also a co-founder at Source Level. I'm going to talk a little bit more about that as well. And now I've joined CloudWalk, which is a global fintech company, mostly operating in Brazil. All of the cities in Brazil have a CloudWalk client in there. And soon we're going to expand into the US as well with this new payment app called Gene.com. And we're using Elixir a little bit in this app too. Just a little fun fact about me, just to end with my introduction. I like to contribute with open source, with a lot of the tools that I deal with my day-to-day. And one of the silly contributions that I'm most proud of is I use NeoVim a lot. And I was the one that added the NeoVim icon into nerd fonts. So if you use nerd fonts, or if you use NeoVim, I was missing a NeoVim icon on nerd font, so I finally got it able to merge that. Such a huge contribution to the open source community there. So yeah, that's me. Yeah, of course. Let's talk about Prophet. Prophet is a Facebook project. It is a time series forecasting tool. It has a paper, an academic paper from 2017. It's a library, simple to use. But it's based on Stan. So Stan is this library. It's more like a language, actually, a platform for modeling statistical events and forecasting tools and other modeling stuff. And we do have actually a binding for that for Elixir, but I gravitated towards NeuralProphet because it's a little bit more modern, has a paper from 2021. A bunch of people from Stanford rewrote Prophet using neural networks, so using PyTorch, and they created this project called NeuralProphet. And both projects, they focus on this idea that the model that you train on your data, you have to be able to understand it, and you have to be able to explain it to other people, which is really useful in a business setting, because when you present a prediction model to, I don't know, marketing people, sales people, the first question they're gonna raise is, why? Why is this model giving me this kind of prediction? Why is that? And if you have a black box model, you cannot answer a lot of those questions. And that's why I really enjoyed reading about NeuralProphet, reading the paper, because they really have this concern on understandability, on explainability, and making things easier to review, to have a human review, and have this kind of arguments and discussion about the model. So, and it's really simple to use. The paper is incredibly reasonable to understand, and pretty easy if you have some experience with machine learning. Not really difficult. And the idea that they have is that the prediction y hat is decomposed into the several components. We're going to go into a little bit of those. So mostly trend, seasonal effects, holidays, regressions. So each one of those components can be understood separately, and of course, they are added in the end. So you have a time series data, usually comprised of multiple periods of interest. So for this example, you have a multi-period, multi-year time series data, and you wanna predict, you wanna fit a model, and of course you wanna predict that into the future as well. And the way that they do that is to break it down into components. So you have a linear trend, a seasonal event, and you can see in the middle, especially like this example, in the middle you can see the yearly seasonality, and you can reason a little bit about it. Oh, you can see that, yeah, every year, some stuff happens every year. Like, oh, maybe in the beginning of the year, our sales in the holidays, our sales are low, but maybe it picks up in the second quarter, picks up some momentum. So stuff like that you can reason about, and you can show that in a chart like this for other people to understand. And in the top chart, you have the linear trend as well. Yeah, let me explain a little bit more in detail about each component. And so you have like so have, for instance, like the linear trend here. You can understood that as a linear trend between each segment. So the cool thing about NeuralProphet is that it can segment the data, and for each segment, it can understand that you have a different linear component to it. And for forecasting, it uses the last one to forecast data into the future, into the unknown. And this is a really cool feature that NeuralProphet has. And if you go into seasonality, the cool thing that they did was to understand seasonality as continuous and periodic function. And of course, if you know a little bit more about machine learning and a little bit more about engineering in general, you can understand that as a Fourier series. You can decompose that into sines and cosines, and that's what NeuralProphet does. You don't need to understand the formula there. But that's the cool idea that they have. Like they get the data and they create new columns in your spreadsheet, in your data frame. You're gonna see that, and you create new columns that corresponds to those sines and cosines terms, and you use that to fit the model and, of course, to predict it afterwards. There's this cool idea of autoregressors in NeuralProphet. This idea that a variable, so past values in a variable, can be used to predict future variables. So you can see the formula here that t depends on y in t minus I. So in the previous in a previous value of y is used to predict the next y, and you can use that. You can configure NeuralProphet to use a lot of those past values, or just one or two, just a couple. You can also use lagged regression, which is the effect of known variables in the past, very similar to how autoregression works, but it's used for other variables. So, for instance, we're talking about sales, maybe sales for AC units. So one of the things that we may want to look into is how the temperature in the area that we work affects our sales data. So you can plug into our data model the variable of the temperature in the area, and you can see how that can help us predict our sales in AC units, for instance. And the same with future regression as well. So you can, if we know certain variables will occur in the future, we can plug that into our model as well. We can plug that into NeuralProphet. So for instance, I don't know, marketing plans, new factors being online that will increase our output for something, salespeople doing more cold calls will increase the input for the sales activity. So this is the kind of thing that you can input in the model as well. And for the last one, holiday effects, which is really, really important for business settings, because, of course, holidays affects sales, affects activities in any kind of business, holidays, vacations, bank holidays, anything like that. So you have this cool idea in NeuralProphet of having all of those components decomposed and working together to predict a variable. And I was, at the time, doing this startup called Source Level. And Source Level, we were doing metrics for engineering management. So we're calling that engineering ops. It was actually a spin-off from Platform Attack, our consulting company. And we were looking to how we could get metrics like pull requests, lead times, and activities from individuals, from teams, organizations. And we wanted to see, we wanted to predict how the teams were doing, to identify bottlenecks, and help the teams, help the managers, and help them to identify those bottlenecks even before they could get into could become a bigger problem. So we had those great tools in Python, but we did not have those tools, a time series tool, in Elixir. So that's why I want to introduce to you a library called Soothsayer. It's a library that is available now. I released it just last week. A few of you have downloaded that, probably myself, doing some experiments on Livebook and locally. Soothsayer is a terrible name for me because I can't pronounce it correctly, but it fits the theme of Elixir. So I didn't want to name it NeuralProphet X, something like that, because I wanted to move away from the religious kind of thing, from prophet, and move into the more Elixir theme of alchemical related, magical, mystical thing, even though I know Jose hates this kind of stuff, but, well, he named the language Elixir, so yeah, let's name it in this theme, right? So yeah, I created Soothsayer. I'm porting a lot of the NeuralProphet features over to Elixir, so that we can have a great tooling for time series data, for time series forecasting in Elixir. So going back to the features of that decomposition that we get from NeuralProphet, where we at with Soothsayer? Actually, let me show you. We just have these two. So right now we can fit a model and give you components related to the trend, to the global trend. So we still don't do the piecewise linear segment trend, and we can give you the seasonal events, so yearly and weekly, but we still cannot do custom seasons yet. But this is actually pretty good already, and of course there's still work to be done. And I'm gonna release some more features next. But this is pretty good already. So yeah, let me show you some code and some Livebook stuff, because it's a Livebook conference, right? Let me switch over to Livebook. Yes, and mirror my screen. Maybe, yeah. So let me show you a little bit about my data. I created here a very synthetic data set to test and to show you how the library can work. You don't need to pay much attention to this code. The thing here is that it's a linear trend, and I use sine and cosine to give it a little bit of a seasonality, a yearly and weekly seasonality with noise too. And create a data range with that, and I create a data frame. So I'm using Explorer's data frame for that. And this is the data. Yeah, let me run that. This is the data that I'm using. Evaluate. Let me run that. This is the data frame here. This is the chart. Let me evaluate the chart. Play button. Should not have to refresh, but... And then it breaks. Yeah, refresh. This is the data. So very simple data, very synthetic data. You can see that's very clearly a linear trend going on here. And of course, a seasonality going on, and very noisy as well. But if my library can't fit into this data series, well, it's a shitty library. So yeah, that's why I created this data series here. And the way that Soothsayer works is that you create a model, and it's just these are the defaults for Soothsayer. So actually, you just need to you don't need to pass all this configuration. It's just here just to show you what kind of configuration we already have. But of course, you can enable, disable those components and pass around how many epochs. You can pass around the learning rate as well. And with the model, you can fit. You can create a fitted model. Let me do that here. You're gonna train the neural network here. It's just 10 epochs, so it's gonna be pretty quick. And with that, we can do some predictions. So I'm running here, soothsayer predict, and I'm appending my original data frame with my predictions into the y-hat column. So I have here my y-hat column. Data frames are awesome in Livebooks because you can see everything in this beautiful format here. And I have here my beautiful graph. Boom! You can see this tomato-colored line is my fitted line, is my fitted model. So you can see it really approximates really well the trend. I can, the code here that I'm using is just Vigalite. It's a custom code because I had to add the color tomato here. But it's just standard Vigalite code. And if we zoom in, I added here a little bit more of a zoom between a few weeks of data. You can see that it really approximates really well those data. But of course, it's a very synthetic data, and yeah, it works. So the other cool thing that I want to show you is that we can see the neural network that is created by Soothsayer. It's actually pretty simple. It's actually, it looks like complicated, but it's not. You can see that each column is about a component. So the first one is yearly, second one is weekly, and the trend. And of course, we add all of those at the end. We add all of those here, and we output the combined components together. But since we also want the individual components later, because maybe we want to show them to some other people, that's why we also want, in our output, we also want all those components individually. So there's a lot of lines going to the output layer here. So very nice way of showing the neural network here. Just a matter of getting the network from the model that we created before, and using this display model from display module from Axon. So very cool thing. And if we plot here our, if we add here into our data frame all of our components. So I have another, instead of using predict, which only gives me the combined prediction, I can use predict components, gives me a map with all those components back, and I can add into my data frame the individual components, so trend, yearly seasonality, weekly seasonality. I can add those into my data frame here, and then I can individually show them to you. So here's the trend. So I can show that very similarly to what I showed in my slides with the NeuralProphet example there. The yearly seasonality and the weekly seasonality. And again, I zoomed in into a few weeks just to give you a little bit of perspective here. And the weekly seasonality here working on. So the cool thing, let me show you a little bit of the code here, because I think it's really cool that the code is actually pretty simple to understand. First of all, we have a preprocessor that its main goal is to add those Fourier terms. So let me add. Let me zoom in. So we can see here that we have all those sines and cosines, and we have the full number of terms for Fouriers, and for year is 6 Fourier terms, so 6 sines and 6 cosines. It's based on the NeuralProphet paper, so I didn't make it up. And that's what preprocessor does. It adds all those columns in the data frame that we pass to Soothsayer. And the cool thing that I want to show you is the model itself. So the architecture of the network here is actually pretty simple to understand. It's an input, a trend input, yearly input, and a weekly input. This is where we can pass all those columns. So in the yearly input, we're going to pass all those sines and cosines for the year. In the weekly input, we're going to pass the cosines and sines for the week. Based on the configuration, we're going to enable or disable the layers, those columns that I showed you in the graph for the network, and we can add here. So this is the layer that adds all the components, creates this combined variable, and this is the final layer that gives me the output layer with the combined component and each individual component at the end. So, and this is really cool because Axon actually, so I was reading through NeuralProphet's code, which uses PyTorch, and I was looking, how can I build my own version of that into using Axon? And man, NeuralProphets, it's actually a little bit hard to understand because PyTorch Axon actually is built upon a really nice layer, is a higher layer of abstraction than what PyTorch is. Even PyTorch Ignite, I guess, is not on par of the abstraction of Axon. Axon is much more descriptive. You describe the layers. You're not computing the layers. You're not. It's not imperative as PyTorch. So this is a really cool code, and I'm not a machine learning expert, and I was able to build this kind of stuff, of course, with the help of LLMs. I used Claude to read through a bunch of Python files, a lot of classes, and I asked, okay, yeah, I want to build that using Elixir, using Axon. How many layers should I use? What's the architecture? And Claude really, really helped me. But of course, I'm not a machine learning expert, and I was able to understand the code, understand Axon's code, and understand this Elixir code pretty easy to reason about. So really, really cool. So yeah, let's go back to my Livebook here with some real data. We have here just a quick demonstration with daily pricing, daily energy pricing from Spain here. Is a CSV from is an example from NeuralProphet actually, and let me show you what the data looks like. So very chaotic at first, going all of the data here, and let's go ahead and fit the data and predict it. Let me show you. It's using how many epochs? I should decrease that. It's using 100 here, but yeah, it's going pretty quick. Okay, 99, it's done. That's my prediction now. So it's not perfect, but there you go. It's a prediction, works pretty well with only trend and yearly and weekly seasonality. If you go over to NeuralProphet's tutorial, it's going to be pretty close to what we have here. Yeah, and just to quickly wrap it up, let me show you. There's a lot of things missing, as I told you. A lot of components to be done. The preprocessor, there's a cool feature that, we need to fill in missing data. For now, you have to do that yourself if you have gaps in your time series value. Also, I want to make that use the same testing data as NeuralProphet does, so makes that easier. And there's one thing that you can do to help me achieve that, which is, of course, please star my GitHub project, Soothsayer. And also, on the right, there's another repo that can help people that are not Elixir people to learn about all this machine learning we're doing, which is this project called, which is a repo called Awesome Machine Learning Elixir, which I'm gathering stuff there to help people that are not so into Elixir to show them, this is the cool stuff that we have in our ecosystem now. So please start that, and that will help me and help our community, I hope. And that's it. Thank you so much.